In this video, we're going to look at determining our key features from a graph. So we're going to look for those things we talked about in the last video, our vertex, our intercepts, zeros, axis of symmetry, those things, but not on the parent function. So on a general parabola that's been moved. Before we do that, I want to remind us about domain and range. So domain is our set of x values. For a quadratic function for a parabola, this will always be all real numbers. If I give you a problem with context, so a word problem, that might change. But if I'm just in general looking at the graph of a parabola with no context, our domain is all real numbers. Range is your set of y values. And that one will depend on the vertex and the direction that the parabola opens, so whether it opens up or down. We'll look at a couple of examples and hopefully you'll understand how to find your range by the end of that. All right, let's look at our first example. So we have the graph. This is our function, but I'm not concerned with this equation just yet. We're going to talk about how to go from this equation to this graph. But for now, we're just going to look at the graph and determine our key features, which are each of these things. I've added domain and range as well. I know it asked for the intercepts first, but I'm actually going to get the vertex first. And before I do anything else, I'm going to determine that since my vertex, which is right here, since my vertex is at the bottom, it's my lowest value, my vertex in this case is a minimum. The point is 1, -4. My x-intercepts are here and here. So my x-coordinates there are -1 and +3. So my x-intercepts are -1 and +3. I'm just going to list them with a comma in between. My y-intercept is right there at -3. It's the y value I'm looking for when I'm looking at my intercept. If I wanted to write that as a point, I could. My axis of symmetry, remember, is the vertical line that goes through my vertex. So my vertical line here that I've done in a red dashed line that goes through my vertex is my axis of symmetry. It divides that parabola in half where the left and the right sides are symmetric, like you can hold up a mirror. Your axis of symmetry will always be x equals, and it will always be x equals the x coordinate of the vertex. So x equals 1. Finally, my domain and range. Remember, for domain, I am going to look to the left and to the right. See how I have an arrow and an arrow? So it goes forever in both directions. My domain is all real numbers. As I said, it will always be all real numbers for all parabolas. I'm going to show you how to write the symbol. It's a capital R with a double backbone. And remember, that means all real numbers. Now, my range, I go top to bottom. So down here, my lowest value is -4. And I've got arrows up there, so it goes up forever. So my range starts at -4 and keeps going up. So y is greater than or equal to -4. Anytime your vertex is a minimum, your range will start with y is greater than or equal to, and it will be your y coordinate of your vertex every time. Again, it's because my y is a minimum, -4 is my smallest value, So my range is y is greater than or equal to -4. And that is it for this first example. Let's look at our second example. Notice this time my parabola is opening down. Now, that does a couple of things for us, including that means our vertex is now a maximum. Your vertex is the highest point on the graph. The value for the vertex is 2, 1. So I went to the left 2 and up 1. So that's my vertex. And it's our maximum. It's the highest point. My x-intercepts are here and here. The x-coordinate at those points are 1 and 3. And my y-intercept is right there at -3. I didn't mean to make my y-intercept the same on both of them, but it really doesn't matter. Remember, my axis of symmetry is the vertical line that goes through my vertex. It's always going to be x equals, and in this case, x equals 2, and it's coming from right there. My domain, as it always will be for a quadratic, is all real numbers. And then be careful with your range. This time when I go to look at my range, this is my highest value, it's 1, and then I've got arrows going down, so I go down forever. This time my range is going to be one, and my y values are getting smaller, so it's a less than or equal to. Again, anytime my vertex is my maximum, my range will be y is less than or equal to whatever the y coordinate is. And that's how we find our key features from our graphs.